Hello all of my dear students, I am Prathamesh welcoming you all to the online platform of Spectrum Academy. Students, if you are in 8th standard, 9th standard or 10th standard and if you wish to prepare for your upcoming board examinations and also your target is then coming the 12th board examinations and the most important JEE or NEET examinations, then this is the right platform for you. I am delighted to announce that we are going to start a new video series on the chapter electricity, which carries a huge weightage in all these examinations, and I can assure you, if you follow the whole series properly, then you will understand each and every single thing related to this topic, not only the basic concepts but the advanced content and the numerical problems as well, which we are going to cover throughout the entire series. So I request you to just stay connected with us and follow the series. Okay, so without wasting our valuable time, let's get started. So people, initially, let me quickly tell you the flow of our whole series. So initially, we are going to discuss the definition of electricity. Then we'll try to understand what is the concept of electric charge. And then we'll try and understand the concept of free electrons. See friends, this particular video, which is the first ever video of this series electricity, is based on the basic content, okay, basic knowledge which is required and essential in order to understand the whole chapter of electricity. Okay, so try and understand every single thing which I'm going to discuss in this session, and then it will be very helpful for you to understand the whole chapter. See, base is the most important thing. If your base is strong, then everything will be easy for you. Okay, so let's start then. First of all, we need to understand what is an electricity. Here I have given you the definition of electricity. First I'll read it and then I'll try to explain. Okay, so the definition of electricity goes like: an electricity is the set of physical phenomena associated with the presence and motion of matter possessing an electric charge. Okay, in simple words, what is electricity? Electricity is a physical phenomena. You must have came across this word phenomena, and a lot of students, they keep on asking me, sir, what is the literal meaning of the word phenomena? So let me tell you here, phenomena is the plural form of the word phenomenon. Okay, it is a plural form of the word phenomenon, and phenomenon means an event occurs in nature, that occurs in nature or in society. Just a minute. Alright. So event which occurs in nature or in society is known as phenomenon. Okay, anything which occurs naturally, that is a phenomenon. Okay, so it's not the difficult thing. Let me clear this once and then we'll proceed further. Just a minute. Let me just clear it once. Alright, we are good to go now. So in electricity, my dear friends, we discuss about the electric charge. So you need to understand what is an electric charge first, then only you'll be able to understand every single thing which is mentioned in the chapter. Moving further, so here we have discussed what is an electric charge and each single important detail about the electric charge. Okay, before going towards all these points, let me make it very clear with one particular example here. See, my dear friends, our memory, human memory I'm talking about, our memory is a photographic memory. Photographic memory means we only understand the matter which we see. Okay, we are able to see the images or videos, or we are able to see it in actual situation. Okay, or else if our brain is able to form its image, then only we can understand the core concept, the matter. Okay, we cannot understand or perceive the things or the information which we just hear. I'll just give you an example so that you will understand. Suppose, what if I say a cow? Okay, what I said? I said a cow. Now all of you must be thinking of a cow, okay, of any color, of any species, that doesn't matter. But yeah, every one of you who was watching this video, they are thinking about any of cow, right? But what if I say a laurel? What I said? I said a laurel. Now you all are blank. But what if I say that in Spanish language we call laurel to a cow? Now all of you are clear what exactly I'm saying. Okay, my point is our memory is photographic memory. When I said cow, you started thinking about cow. There was an image at the back of your mind. But when I said laurel, there was nothing at the back of your mind. Okay, the brain was unable to form image. That was just a word for you which sounded so weird. Okay, but when I said that in Spanish we call laurel to a cow, then everything was clear. So I hope you understood what exactly I'm trying to say. In order to understand electric charge, we need to form a picture of it, okay, at the back of our mind. So just to do that, we need to know the concept of an atom. You must be knowing an atom. What is an atom, my dear friends? Atom is the smallest particle of matter, right? In simple way, how can we define atom? The smallest particle of matter, that is an atom. Okay, now how atom looks like? Okay, so if we try to draw the image of an atom, it will look something like this. Suppose, yeah, here, let me draw here so you all can see very properly. So atom consists of a nucleus, centrally placed nucleus, which is spherical in shape, okay, and this nucleus contains two entities. Basically, one is proton and other one is neutron. Proton, they carry positive charge, and neutron, they are chargeless, they don't carry any charge, they are neutral particles, okay. And around this nucleus you'll see such spherical orbits, okay, not exactly spherical, or else, yeah, in some cases they are spherical, okay. So these spherical orbits or shells we call, okay, and in these shells you'll see various revolving electrons which are just keep on rotating, keep on revolving around this nucleus, okay. So these electrons, they carry negative charge. Now my dear friends, here we can understand that there are two specifically charged particles. One carries positive charge and another one carries negative charge, okay. So there are the two types of electric charges. One is positive charge and one is negative charge. So moving on further, see here, electric charge. So here I have given you a definition of electric charge. What is the definition? The definition is very easy. The physical property of matter that cause it to experience a force when placed in an electromagnetic field. What is the meaning of it? It's very easy, okay. Before understanding this particular concept, let me give you another example. Suppose we have a magnet, okay, and what if I place a magnetic material just near to this magnet, any magnetic material, let's say a material made of iron. So this magnet will exert a force which would be of attractive type, okay. So this magnet will exert a force on this material and this material will get attracted towards the magnet. So this force is known as magnetic force, and the field surrounding this magnet, in which any other material either experiences an attractive force or repulsive force, that field we call it as magnetic field, which has notation capital B. Similar to the magnetic field, we define another concept known as electric field, just in case of electric conductors. It's very easy again. What is an electric field? Electric field is the field surrounding any type of electric conductor in which any other electric material or any other electric charge will experience a force. Suppose if I have a conductor, this is a conductor, okay, which carries electric current through it, let's say I, and if I place any type of electric charge or any other electric material just near this conductor, so there will be a field surrounding this conductor inside which this another material or any charge will experience some force, either attractive or repulsive. This field is known as electric field, and we define it or we denote it with the letter capital E. So now the combination of electric field and magnetic field both is known as electromagnetic field. So electric charge is an entity. What is an electric charge? Electric charge, it is an entity which experiences a force, either attractive force or repulsive force, when we place it in the electromagnetic field. Okay. What is the symbol of electric charge? The symbol is either small q or capital Q. You can use either of the letters if you like in some cases in some special cases, like if we denote net charge, in that case we usually prefer to use capital Q, but yeah, in some cases you can use small q also, just to denote the electric charge. Okay, now what are the units? The SI unit of electric charge is coulomb, while the CGS unit is electrostatic unit. The symbol goes like ESU, all letters are small, ESU, electrostatic unit. That's the CGS unit of electric charge. Now types. Electric charges are of two types, as I said earlier. Electric charge can either of it can be a positive type, which is termed as proton, okay, and it can be a negative, which is termed as an electron. Okay, so these are the two types of electric charges: positive proton and negative electron. Okay, now there's one of the important property of electric charges, that is, like charges will always repel each other. On the other hand, unlike charges will always attract. What it means, suppose if I have a positive charge in contact with another positive charge, so these are the two like charges, similar charges. So similar charges, they will always repel each other. Try and understand, this is actually the natural, you can say, rule. Okay, what is it? Two similar things, they always repel each other, and two opposite things, opposite in nature, they always attract each other. Okay, just like north pole of magnet always attracts south pole. Okay, if you place north pole in contact with north, you'll see there's a repulsion. Okay, so in the same way, in similar fashion, in case of electric charges, if you put like charges in contact, they'll repel each other, and unlike charge, suppose you have positive one and another one is negative, then these two charges will repel each other. Okay, now the next term is electrically neutral object. Again, this is one of the important term as far as the electricity is concerned. Okay, electrically neutral object. What is electrically neutral object, my dear friends? Electrically neutral object is an object which carries no net charge. So here's a term, net charge. What is the meaning of the term net charge? Net charge means total charge. Okay, let's say, let us consider an example. Suppose we have this object which contains two positive charges, that is protons, and two negative charges. Okay, so the number of charges are same. Positive charges 2, negative charges 2, so they are equal in number. So the effect of both the charges, it will be nullified. The total charge on the system will be 0. Why? Because we have same amount of positive charge, same amount of negative charge, they cancel each other. Okay, suppose if I have two positive charges and only one negative charge, then positive charge will be greater in number and the net charge on the system will be positive. Okay, on the other hand, if I have negative charge more, positive charge less in number, then the net charge on the system will be negative, obviously. But if the two, like positive charge and negative charge, both are equal in magnitude, then the whole charge, the total charge on the system remains 0. that is what we call as net charge on the system is 0. So if the net charge on any system or object is 0, then we call that object or system as electrically neutral. That means no charge. Okay, no charge means the total charge is 0. Try and understand. Okay, fine. So let us move further. Yeah, so here the last point about the electric charge which is important for you is magnitude of each charge. Suppose I have one proton and I have one electron. What will be their magnitude? First, let us discuss about the word magnitude. A lot of students, they fail to understand the meaning, literal meaning of the term magnitude in physics. What is it? My dear friends, it's a product. Magnitude is what? It is a product. Product means, see, in mathematics we have 4 basic operations: addition, subtraction, multiplication and division. The third operation, multiplication, we call it as product, and the last one, division, we call it as quotient. Okay, so here I'm talking about the third operation, that is multiplication. Multiplication also goes by the name product. So magnitude, similar way, magnitude is also a product, means it is a multiplication. Multiplication of what? Multiplication of any numerical value multiplied by unit of a physical quantity. Numerical value means number, my dear friends. So suppose you have a number and you multiply it with any unit, then whatever you get, that is a magnitude. Okay, for example, suppose I say my mass is 65 kg. Okay, what I'm saying, my mass is 65 kg. So here 65 is a number, it's a numerical entity, and kg is a unit of mass. So together 65 kg forms a magnitude. Suppose I say the force acting on a particular object is 10 Newton. What is the force? Force acting is 10 Newton. 10 is a number and Newton is the SI unit of force. So 10 Newton together forms a magnitude. Okay, I hope you all are clear with the term magnitude. Alright. So what I have written here, what the point is, magnitude of each charge. Suppose like I have positive charge or else the negative charge, one positive or one negative. Basically we denote charge with the letter small e. Small e means literally it means a charge. Okay, either positive or negative, it can be anything. So the magnitude of a single charge, either proton or electron, what is the magnitude? 1.602 into 10 to the power minus 19 coulomb. If you're not able to see, because it seems it's small, okay, the font size is small for this video, I'll just write down here so you won't have any confusion. The magnitude of a single charge is 1.602 into 10 to the power minus 19 coulomb. Remember, coulomb is the SI unit of electric charge. Okay, so if you have a single proton, it carries 1.602 into 10 to the power minus 19 coulomb, or else if you have an electron, then the magnitude will be minus 1.602 into 10 to the power minus 19 coulomb. Okay, so that was about the magnitude of either electron or proton. I hope it's clear to you. Now let us move on to the next slide. Yeah, so here's the, I guess it's the last slide, last point of this session. It's a free electron. What is a free electron? Let me read the definition first. The electrons that are loosely bound with a nucleus of the atoms and are free to move within the conducting material. Here I have given you a picture to make it very clear or to understand it in a better way. Suppose we have an atom. Okay, this centrally placed spherical shape is nucleus, obviously, and nucleus contains, as I already told you, nucleus contains two entities: positively charged proton and neutral neutron. Neutron carries no charge. Okay, and around the nucleus you'll see various orbits or shells in which you'll see various electrons that are revolving around the nucleus, and electrons, they carry negative charge. So what I mean basically is, atom has a nucleus, spherical nucleus, which carries positive charge known as proton. Also it carries some neutral species which carry no charge, and around the nucleus you'll see various orbits. And within these orbits, we find electrons carrying negative charge, they are revolving. Okay, so suppose I consider two different electrons. Okay, this is the first electron, okay, and this one is the second electron. Now, one basic thing, see, this electron and the proton which is present inside the nucleus, both of them, they will have the electrostatic force of attraction. Okay, I've already told you the two opposite things, they always attract each other, right? So proton, it has positive charge and electron has a negative charge. So the two opposite charges are present, they'll attract each other. Okay, so in between electron which is revolving okay, around the nucleus within the specified orbit and the proton present in the nucleus, they have attractive force. Consider the first electron and this one. Okay, actually there are three electrons, but I'm calling this as first and this one as second. Okay, we are not considering the third electron. Okay, just focus on these two electrons. This is the first and second. What do you think? For which electron the force of attraction is more in magnitude, higher in magnitude, first or second? Yes, right, you're right. The force of attraction in the first case is high in comparison to the second case. Why? It's just because of the distance. If you look here, the distance and the distance in these two, like, okay, the second case, distance is large in this case and it is smaller in this case. So distance is inversely proportional to force of attraction. If you increase the distance, force of attraction will be less. If you decrease the distance, force of attraction will be high. So here in this case the force of attraction is high, and in this case the force of attraction is very low. So this particular electron can be made free easily from this atom and it can revolve within the material. So all those electrons which are loosely bound, okay, the electrons which have very weak force of attraction, to understand it's very easy. What are the free electrons? Free electrons are those electrons which are loosely bound to the nucleus, which have low or weak force of attraction, okay, with the nucleus, are called free electrons, and they can easily move within the material freely. Okay, how? See, yeah, so what we are discussing about the free electrons. So what are the free electrons? Those electrons which are loosely bounded with a very weak force of attraction. So what happens actually? What is the scenario of free electrons? Suppose this is a material. Now, see, as far as electricity is concerned, we define materials in two categories: materials which are good conductors of electricity and materials which are bad conductors of electricity. The reason behind it, if the material is good conductor, it simply means that the materials possess free electrons. And if the material is bad conductor, the number of free electrons are either very less or they are not present anymore. Okay, so if the free electrons are not present or they are very less, then the material becomes electrically bad conductor. And if the number of free electrons, they are enough in number, they are high in number, then the material becomes electrically a good conductor. So what happens? Suppose these are the free electrons. These dots, they represent the free electrons. These free electrons, they help in the conduction of electric current within this material. They are electrons which have very weak force of attraction, and on the application of voltage, see, this is the higher part. Okay, we are going to study everything, voltage and everything, how electric current gets produced in upcoming sessions. This is just the introductory lecture. The purpose of this particular video lecture is to make you aware, try and understand the basic matter which is required to understand the concept of electricity, the whole chapter of electricity. So that was about free electrons. I hope you all people must have understood electrons which are loosely bounded with very weak force of attraction to the nucleus, and they can move within the material very freely. Okay, so that was about electricity, my dear friends. This is Prathamesh signing off the session Electricity. I'll see you soon in my next lecture, and don't forget the most important thing, okay? All your friends, those who are preparing for the same examinations, okay, don't forget to share this video link with your friends so they also can get the benefits, okay? And don't forget to subscribe our channel Spectrum Academy. Thank you. Have a nice day. Take care.